Welcome back, guys. Hope you're doing well. I'm going to go ahead and share again so that we can take a look at what we're going to be doing next. We are on question 2. So I'm going to pull over my paper here and let's see if we can manage this. So question 2 says, given 15.6 liters of water, gaseous water, H2O gas, how much hydrogen peroxide can be formed in the presence of excess O2, considering that H2O gas plus O2 gas goes to 2H2O2 gas. Okay, so they gave me that. I know that I have an excess of O2. So I know my 15.6 liters is going to be what's limiting me, because no matter how much I have, it can't be as much as the excess that I have of the other. That's what that excess means. I also know that all of these things are in the gas phase. So chances are I'm going to be working with one of my gas laws. Now, the gas laws that I have available to be working with are of two forms. One is where I'm changing conditions, and one is where I'm using the state of the gas to try and figure out one of the other components. So let me think for just a second. That's right. So what I'm trying to do is go from this liters to moles, and that's liters of H2O, to moles of H2O, to moles of H2O2, and that's what they ask me, is how much do I form? Now, I don't have to say whether that's volume, or i.e. number of moles, or volume, but that tends to be how I put this together. That way you can see the part. If you want to stop somewhere, you can stop there. And one of the things that we have to remember is that the molar volume of a gas is 22.4. So 1 mole of gas is 22.4 liters. Now that's an STP. You know, there are a lot of caveats that are given to that, but I'm not told that I'm at any conditions that would preclude me from thinking that's where I am. Okay, so you are safe to use that. So if that's the case, I can take my 15.6 liters, and all my calculations always start with the information that they gave me. So I start with my 15.6 liters of H2O gas. I'm going to use this 1 mole of gas as 22.4 liters, and I'm going to divide by 22.4 liters and have 1 mole of gas on top. And of course, that gas, in this case, is H2O. Okay, so now I have moles of O2. So I've gotten through this part. I'm in moles of O2. Yay, I got part of the way there. All right, to go from moles of H2O, moles of H2O, if I know moles of H2O and I want to go to moles of H2O2, I need the molar ratio between the two of them. Now, I get my molar ratio from the balanced equation. So that is written right here. So I know that 2 moles of H2O consumed makes 2 moles of H2O2. Sweet. Now I can stop right there and use that answer. Whatever that answer comes out to be, I can use that. But I can also go backwards. 22.4 liters per 1 mole. And that should get me what I'm looking for, right? So let's see if we can pull up a calculator, because that's always helpful. I don't trust my math anyway. So I'm going to pull, clear that, and I'm going to pull this over here, hopefully. Hopefully. So again, we have 15.6 liters. We divide that by 22.4. That tells me how many moles I have. Since I know it's a 2-to-2 or 1-to-1 ratio, I can stop. I cannot do this calculation, but I will literally freak out if I don't. So I'm just going to say, yes, that's actually the case. And then if I wanted to go back to volume, I would go there. All right. So 15.6. Woo, awesome. So 15.6 liters is how much I can make. Now, the only reason that that works the way that it does is because the stoichiometry of the equation is what it is. We have 1 mole of H2O per 1 mole of H2O2, i.e. 2 moles of H2O per 2 moles of H2O2. And because I'm working with a gas that's under standard conditions, okay? So we can do that. That's awesome. So that gives me 15.6 liters of H2O2. Now, would it be possible for you to write other things on the test? Absolutely. You can tell me that you recognize that the stoichiometry is 1-to-1 or 2-to-2 or whatever, and so then you can say that you know that this has to be the same volume on both sides, because no matter what the gas is, the volume that 1 mole occupies is the same. So those are things that I can see, but I need to see something to show me how you know that these are the same. Okay? So that is number 2. Questions, comments, problems on number 2. Hopefully not, but that's where we're going to end with number 2. I am going to pick this up with number 3 in the next video, and I will see you again soon.